Dear friends, World Teachers' Day greetings to everyone. As you know, Maths Aspirants is a collective of mathematics students, research scholars, and faculty members across India, initiated by myself in 2017. And since the time of COVID onwards, we used to organize several online programs like online problem solving sessions and online test series to help the students who prepare for different national level competitive examinations like CSER, NET, GATE, IIT, JAM, etc. As a part of that online problem solving session series, we have a session on linear algebra today. Actually, this session is in continuation with the previous session taken a few weeks before by Miss Ardra. So today we blessed to have Miss Ardra, a research scholar from University of Hyderabad, with us to handle a session on linear algebra. So I'm sure that today's session will be really beneficial to everyone who are seriously preparing for different competitive examinations. I would like to express my sincere thanks and gratitude to Ms. Ardra for being with Math Aspirants. I welcome everyone to this program. Welcome, Ardra.
Good morning, everyone. And thank you, Vinod sir, for giving me this opportunity. So today is a special day, World Teachers Day. So happy Teachers Day to all the teachers here and all the future ones also. So coming to the session, in today's session, we will be discussing finite dimensional vector spaces, which is one of the important topic in linear algebra. Mainly, I am focusing on the syllabus of IIT JAM. However, I have added the questions from CSAR NET also. So those who are preparing for CSAR NET and GATE also, they can also take benefit from this class. They can brush up the basics and practice the question. So let us start. So here is the mark distribution of linear algebra for various examinations. From this itself, we can understand the importance of linear algebra. It's very important to understand each and every concepts of linear algebra for scoring good in competitive examinations. Here is a syllabus of IIT JAM linear algebra. Two sections are there, matrices and finite dimensional vector spaces. In the last class, we have already discussed the matrices part. We have practiced many questions related to system of linear equations, eigenvalues, eigenvectors, rank, etc. So in today's session, we will be discussing the questions related to subspaces, basis, dimension, linear transformation, metric representation, and all. So as we have discussed in the last class, the main goal of the linear algebra is to develop effective techniques to solve the system of linear equations. So to solve system of linear equations, there are two methods. One is by the method of matrices and second is by the method of linear transformation. So in the last class, we have discussed how we are converting the system of linear equations to matrix equation and solving it using the properties of matrices. Here let us see how we are relating system of linear equations to linear transformations. For example, consider the following system. 2x plus 3y plus 4z is equal to 3. 4x plus 6y plus 5z is equal to 6. So here we have two linear equations in three unknowns, x, y, z. So the question of system of linear equation is that whether there exists x, y, z such that satisfying these two conditions. So how to convert it into a linear transformation? Let T from R3 to R2 be T of xyz is equal to 2x plus 3y plus 4z, 4x plus 6y plus 5z. Then the question comes, does 3, 6 belongs to the range of T? If 3, 6 belongs to this range of T, then we can say that there exists x, y, z satisfying these two conditions. So for a linear transformation, we need vector spaces. So let us start by the definition of vector spaces. I know almost all students know, but we can just start with the basic definitions. So here is the definition of vector space. Let F be a field. We are taking an abelian group V comma plus, and if we have a map star from F cross V to V satisfying these four conditions, then we say that V comma plus comma star is a vector space over the field F, and the star operation is called the scalar multiplication. So what is a subspace of a vector space? A non-empty subset W of V is a subspace of V if and only if for each pair of vectors alpha beta belongs to W and each scalar C belongs to F, the vector C alpha plus beta belongs to W. So in the perspective of competitive examinations, their main focus is for subspaces. They will be given some vector space and they will give some subsets of this vector space, and they will ask the question whether this is a subspace or not. So understanding this definition of subspace is very important. A subspace of V if and only if for each pair of vectors alpha beta belongs to W and each scalar C belongs to F, the vector C alpha plus beta belongs to W. So let us see some simple questions related to subspaces. You can try this question. I will give 2 minutes time. You can try. Anyone?
C.
C. Yes, correct. So I'm starting explaining the solution. So here it is given that V is the vector space consisting of all polynomials in one variable with real coefficients and having degree at most 6 together with the zero polynomial. Okay. So this is one of the important vector spaces for competitive examinations. They will be asking most of the questions related to this polynomial space. So polynomial space means if n belongs to natural number, then the set of all polynomials of degree at most n with coefficients from a field F is a vector space over F denoted by Pn of F, and the elements of Pn of F is equal to set of all a0 plus a1x plus etc. plus an x raised to n, such that coefficients are from the field F. So here they have given 4 subsets and they are asking which one is the subspace of V. So in such questions, first we have to check whether the zero of the vector space V belongs to a subset or not. So here the V is the polynomial space. So what is the zero of the polynomial space?
Null polynomial.
Yes, null polynomial. That means all the coefficients are zero, right? Yes. So here we can analyze each of the options. First option is saying that set of all f belongs to V such that f of 1 by 2 doesn't belongs to rational numbers. But if we are taking the zero polynomial, then f of 1 by 2 is equal to 0. It belongs to the rational polynomial. So in this case, zero polynomial doesn't belong. So option A is discarded. Similarly, if we take option B, f belongs to V such that f of 1 by 2 is equal to 1. But if we are taking zero polynomial, then f of 1 by 2 is 0 only. So B is also discarded. Similarly, we can discard D also, and option C is the correct answer. Even you can verify this option C using the definition of subspace. So option A, B, D can be discarded. Thus, the answer is option C. So whenever some such questions come, first check whether zero of the vector space belongs to this subset or not. Maybe by just analyzing this, we can discard all the three options and we can reach to the correct answer. Okay, so let us move to the next question.
Yeah, I have a question.
Yes.
Ma'am, if option A, if you please go back to the page here, right? So in option A, if this will be given that f belongs to V such that V of f of half belongs to Q, that is rational. So
Okay, f of
then also it will be not a vector space of V, right?
no, it will not be. You can take some scalar like root 2
Irrational number,
of
right?
yes, yes.
Uh,
Okay. So let us move to the second question. You can try. I will give 2 minutes time. This is a question from JAM 2023. Yes, option A. Let us wait for other answers also.
Option A.
Okay. Any different answer?
Option D.
Option D. Okay, so many have answered option A. Option A is the correct answer. Let us see the solution. So here we are given the 4 subsets of R3, and the question is to check whether it is a subspace or not. So coming to the option D, we can just discard option D. How? Can anyone say?
Allocation there.
Yes, 0 of this vector space is not present. That means 0 is not present, because if we are taking 0 then 0 plus 0 minus 0 plus 1. That means we are getting 1 is equal to 0, which is not true. So option D is discarded by taking 0. Now coming to option B, can you say some counterexample?
Which option, ma'am?
Option B. How you discarded
Taking,
option B?
uh, taking
It's
second
as root
coordinate as
2.
irrational.
Okay, second coordinate as irrational. So it will not belongs to this, no?
Taking scalar as an irrational number.
Scalar as an irrational number. Yes, correct. Yes. So, uh, so we can just take say like 0, 1, 0 and just multiply it with a irrational number like root 2 into 0, 1, 0. Then it will not belongs to this subset. So it is not a subspace. Good. Then what about option C?
Not closed under addition. We can
Not.
take 0, 1,
Hmm.
0 and 0, 0, 1.
Yes,
If
correct.
we add them, that not satisfied.
Yes, correct. So, so for option B, you can just take, and as he has mentioned, you can just multiply it by an irrational number, so it will not belongs to this set. And for option C also, if we are taking 0, 0, 1, 0, 1, 0, then its addition is 0, 1, 1, which doesn't satisfy this yz is equal to 0 condition. So option C is also discarded. So option A is the answer. You can verify this option A also. Like here you can see that y plus z whole square plus 2x minus 3y whole square is equal to 0. And this is a real numbers. We are in real vector space. So here y plus z whole square plus 2x minus 3y whole square is equal to 0 implies that y plus
Two
z is equal
individuals
to,
has to be 0.
yes, individual have to be 0. So we will get y is equal to minus z and 2x is equal to 3y. So by this, you will get that this is a subspace. You just have to analyze, but you will get that it will be a subspace. So I hope that this question is clear. Any doubt?
No, ma'am.
Can we, okay. Can we move to the next question? Okay. So here is one of the other results that we have to keep in mind related to the subspaces of V. If W1 and W2 are subspaces of V, then W1 intersection W2 as well as W1 plus W2 are also subspaces. W1 plus W2 means it is the smallest subspace containing W1 and W2. Okay. So if W1 and W2 are subspaces of V, then W1 union W2 is not a subspace in general, but it will be a subspace if and only if one is contained in another. So keep these results in your mind while dealing with the questions of subspaces. So now we know that if we are taking a vector space, the elements of vector spaces are called vectors. So there will be infinite number of vectors. If we are just taking R over R, then there are infinite number of real numbers. That means there are infinitely many vectors. But the question comes whether there is a special set of vectors which will give a whole idea of the vector space, or which will give the whole vector spaces. Yes, there is a special set and it is called the basis of the vector space. So a basis for a vector space V is a linearly independent set of vectors in V which spans the space V. So what is a linearly independent set of vectors? A subset S of V is said to be linearly dependent if there exist distinct vectors alpha 1, alpha 2, etc. alpha in S and scalar C1, C2, etc. Cn in F, not all of which are 0 such that C1 alpha 1 plus C2 alpha 2 plus etc. Here 1 plus is there. Cn alpha n is equal to 0. A set which is not linearly dependent is called linearly independent. Now coming to the definition of linear span, the linear span of a non-empty subset S of vector space V over F is defined as the set consisting of all linear combinations of elements of S and it is denoted by span of S. In fact, this span of S is called the subspace generated by the subset S. And number of elements in this basis is called the dimension of vector space V over F. So in perspective of competitive exams, question will coming, they will give some subset of the vector space. And if it is a subspace, we have to determine the dimension of the subspace. So the questions will come accordingly. So you have to understand the definition of linear independence as well as the linear span. So let us see how the questions are asked related to these concepts. This is a question from IIT JAM 2025. Here we are given 4 vectors u1, u2, u3, u4. They are asking the question whether they have taken u1, u2, u3, u4 as well as they have given some linear combinations of u1, u2 and they are asking whether they are linearly independent or not. So you can try, I will give 2 to 3 minutes. If you are hesitated to say the answer, you can type in chat box also. I can see the chat.
A is true, ma'am.
Okay, A is true. It is a multi-select question. So you can,
The rest I am trying.
okay.
C is false.
Okay.
A and B are correct.
A and D. You can check once again. Yes, option A is true.
A and B.
A and D,
B, B.
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 Okay.
A and B.
Okay. Yes, I can see many correct answers in the chat box also. Good. So let us see the solution of this question. Here we are given 4 vectors u1, u2, u3, u4, and they are asking the question related to linear independence. So let us convert these vectors into a matrix. Write the u1 vector as the first row, u2 vector as the second row, u3 as the third row, and u4 as the fourth row. So we will get a matrix like this: 1 0 0 1 0 0 minus 1 0 2 0 minus 1 0 0 1 minus 1 0 0 0 1. And if this matrix is a non-singular matrix, or we can say that if its rank is equal to 4, then this will be a linearly independent vector. So this will be a linearly independent set, or u1, u2, u3, and u4 are linearly independent vectors. So here we can say that this matrix is a triangular matrix, and all the diagonal entries are non-zero, and hence this will be a non-singular matrix. What is meant by non-singular matrix?
Determinant non-zero.
Yes, determinant non-zero. So we got that u1, u2, u3, and u4 are linearly independent. Now let us come to the option C, because both are similar only. So this also we can convert into a matrix form, right? u1 minus u2, u3 minus u4. So this is the matrix associated with u1 minus u2, u3 minus u4. So here we can see that this is also a triangular matrix, and it is a non-singular matrix. And hence u1 minus u2, u3, and minus u4 are linearly independent. But in option C, it is given that it is not a linearly independent set. So option C is discarded. Is it clear till now?
Yes, ma'am.
Okay. So now we got that u1, u2, u3, u4 are linearly independent. And the option B and option D are asking some of the linear combinations of these vectors. So how to do this? Coming to the option B, let us write alpha 1 into u1 minus u2 plus alpha 2 into u2 minus u3 plus alpha 3 into u3 minus u4 plus alpha 4 into u4 minus u1 is equal to 0. According to the definition of linearly independent vector, we should get that this all alpha 1, alpha 2, alpha 3, alpha 4 must be equal to 0. Isn't it? If u1 minus u2, u2 minus u3, u3 minus u4, u4 minus u1 are linearly independent. Okay. Now, we know that u1, u2, u3, u4 are linearly independent. So, let us combine those terms, those coefficients. So, we will get alpha 1 minus alpha 4 into u1 plus alpha 2 minus alpha 1 into u2 plus alpha 3 minus alpha 2 into u3 plus alpha 4 minus alpha 3 into u4 is equal to 0. Since u1, u2, u3, u4 are linearly independent, its coefficient must be equal to 0. That means here alpha 1 must be equal to alpha 4, alpha 2 must be equal to alpha 1, alpha 3 must be equal to alpha 2, and alpha 4 must be equal to alpha 3. That means alpha 1 is equal to alpha 2 equal to alpha 3 equal to alpha 4. But it doesn't imply that these are equal to 0. Maybe if these all 4 are equal to 1, then also we will get this equation. So this implies that u1 minus u2, u2 minus u3, u3 minus u4, u4 minus u1 are linearly dependent. Okay. So option B is saying that it is not a linearly independent set in R4. So option B is also correct. So similarly, we can analyze the option D also. You just take alpha 1 into u1 plus u2, alpha 2 into u2 plus u3, alpha 3 into u3 plus u4 plus alpha 4 into u4 plus u1 equal to 0, and combine the coefficients of u1, u2, u3, u4. And since these are linearly independent, it must be equal to 0. Coefficient must be equal to 0. Here also we will get an equation like alpha 1 is equal to minus alpha 4 is equal to alpha 3 is equal to minus alpha 2. But it doesn't imply that these are 0. Only if we get these are 0, we can conclude that u1 plus u2, u2 plus u3, u3 plus u4, u4 plus u1 are linearly independent. But from this information, we can't conclude that these are equal to 0. And hence, these vectors are linearly dependent. So in option D, it is saying that it is a linearly independent set in R4. So option D is also discarded. Hence, option A and B are correct. I hope that the solution is clear. Any doubts? Can we go to the next question?
Yes, ma'am.
Okay. So here is also a question related to linear independence. Let P1 of x be the real vector space of polynomials in the variable x with real coefficients and having degree at most 11 together with the zero polynomial. Here we are given two sets E and F, and they are asking about the linear dependence and independence. So as I have mentioned earlier, in the perspective of competitive examination, the real vector space of polynomials is very, very important. So understanding this real vector space, what are its subspaces, or what is the basis of the vector space, as well as what is the dimension of this vector space are very, very important. So try this question. You can take 2 to 3 minutes. Yes, option B is correct answer. Let us wait for others also. So I can see many correct answers in the chat box. Good. So let us start discussing the question. So here is the real vector space of polynomials having degree at most 11. E is the set such that S naught of E is the set S naught of x, S1 of x, etc. S11 of x, such that S naught of 3 is equal to S1 of 3 is equal to S11 of 3 is equal to 0. And F is a set R naught of x, R1 of x, etc. R11 of x, such that R naught of 4 equal to R1 of 4 is equal to R11 of 4 is equal to 1. Then what can we say about this set E and F? So first consider the set E. Take the linear combination alpha naught S naught of x plus alpha 1 S1 of x plus etc. plus alpha 1 alpha 11 S11 of x is equal to 0. So in order to be S naught of x, S1, etc., S11 to be linearly independent, we need all the coefficients to be equal to 0. But here we have given a condition that at the point 3, this S0, S1, etc., S11 is equal to 0. So we will get that for x equal to 3, we get alpha naught into 0 plus alpha 1 into 0 plus etc. Alpha 11 into 0 is equal to 0. But it doesn't imply that these are 0 because S naught of x are equal to 0, we are getting this equation. Maybe here alpha naught may be 1, alpha 1 is equal to 0 and alpha 11 may be minus 1. In that case also we are getting it is equal to 0. So from this we can't conclude alpha all the coefficients are 0 and hence E is necessarily dependent. Okay. Similarly, considering the set F, take the combination beta naught R naught of x plus beta 1 R1 of x plus etc. plus beta 11 R11 of x. So according to the given condition, this coefficients at 4 is equal to 1. So we are getting beta naught into 1 plus beta 1 into 1 plus etc. plus beta 11. So this is equal to 0. May or may not implies beta i's are zeros. Maybe here all the coefficients are 0 or it may not be 0. So we can't conclude anything. We can't say that it is linearly dependent or linearly independent. So it's not necessarily linearly dependent. And hence option B is the answer.
Ma'am,
I hope that
in the second F set,
huh,
uh,
huh.
you got beta naught plus beta 1 up to beta 11 equals to 0. Now,
It's not equal to 0. I'm just taking this combination. If these are means if R naught of x etc. R11 of x is linearly independent, then we need each coefficient is equal to 0.
no, ma'am, I am asking that if we have to check the linearly dependency of of a set, you have to uh, write in C1 V1 plus C2 V2 up to Cn Vn equals to 0, and then
Yes.
take it as if C1's all Ci's are 0 or not. If all Ci's are 0,
Huh.
then it will be linearly independent, right?
Yes,
So
yes.
if we taking beta naught beta 1 up to beta 11 equals to 0, then
Hmm.
here uh, if all beta i's are 0, then it will not satisfy the equation, right? So it is not necessarily linearly independent. But what about dependency? We will not conclude here, right?
No, we can't conclude here. That's why I say it's not necessarily linearly dependent as well as it is not necessarily linearly independent also.
Okay, ma'am, please explain the first option again.
Huh. First option, we are taking alpha naught of s naught of x plus alpha 1 s1 of x plus etc. plus alpha 11 s11 of x is equal to 0. So if these s naught, s1, etc., s11 are linearly independent, then we should get that this alpha naught, alpha 1, etc., alpha 11 are equal to 0 in every case, because here we are having x variable. So for all x we need to get this. But for
Okay.
x equal to 3, even if alpha naught may not be 0, like if it is 1, in that case also we are getting 0. So this doesn't imply that alpha i's are equal to 0. But in case of f, we are this s not r naught of x are just the value 1. So we can't conclude whether it is a linearly dependent or linearly independent. But in the first case, for s naught of x means at point 3, all these s naught of x, s1 of x, etc., s11 of x are 0.
Yeah.
Okay. So they are asking from this condition whether we can conclude something.
Okay, ma'am. Clear.
Okay. Okay. Any other doubt? Okay, so let us see one note here. Let V be a vector space of dimension n, then any subset of V having more than n vectors is linearly dependent. And if let S be a subset of V having n vectors, then S is linearly independent if and only if L of S, that means the span of S is equal to V. So keep this in mind while analyzing the questions related to linearly independence as well as span set. Okay, now let us move to the next question. This is a question from IIT JAM 2025. Question related to the span of a set. So they have given 5 subspaces V1, V2, V3, V4, V5, and they are asking which one of them is a subspace, like V1 union V2, V1 union V3, V1 union V4, V1 union V5. Okay, so here just keep in mind the result that we have discussed before. If W1 and W2 are subspaces of V, then W1 union W2 need not be a subspace in general, but W1 union W2 is a subspace if and only if one is contained in the other. So using this result, analyze this question.
No, it is single correct or multiple correct?
It is multiple correct.
I think C is true.
Okay, try other options also. So I can see option A is false. Yes. Yes, option C and D are correct. Okay, so I can see correct answers in now chat box. Option C and D are correct. Okay, so let us see the solution. So as I have mentioned, we just have to use the result. If W1 and W2 are subspaces, then W1 union W2 is a subspace of V if and only if one is contained in the other. Okay, so here we can see that W1 is having dimension 2. Here you can see that this 1, 2, 3 and 1, 1, 0 are linearly independent, and hence B1 is having the dimension 2. Okay. Now, to check whether V1 union V2 is a subspace of R3, we just have to check whether V2 is contained in V1 or not. V2 is contained in V1 means we have to get this vector 1, minus 1, 0 as a linear combination of 1, 2, 3 and 1, 1, 0. If we can write 1, minus 1, 0 as a linear combination of these two vectors, then we can say that V2 is contained in V1. Similarly, others also V3, V4, V5, we can analyze the same. So let us see whether we can express 1 minus 0 as a linear combination. So before analyzing the option A, let us revise the result. Span of U is the smallest vector subspace of V containing U. And if U1 and U2 are subspaces of V, then U1 union U2 is a subspace of V if and only one is contained in the other. Now coming to the vector 1 minus 0, we can write it as alpha. Suppose 1 minus 0 is equal to alpha into 1, 2, 3, comma beta into 1, 1, 0. That is alpha plus beta, comma 2 alpha plus beta, comma 3 alpha. That means alpha plus beta is equal to 1, 2 alpha plus beta is equal to minus 1, 3 alpha is equal to 0. So by comparing this equation, we will get that alpha is equal to 0. And if alpha is equal to 0, then from first coordinate, we will get that beta is equal to 1. And from the second coordinate, we will get that beta is equal to minus 1. But this is impossible. And hence, 1 minus 0 cannot be expressed as the linear combination of 1, 2, 3, 1, 1, 0. Okay. So similarly, option B, it is asking V1 union V3. And V3 is the span of 1, 1, 1. So let us see whether it can be expressed as the linear combination. So here 1, 1, 1 is equal to alpha into 1, 2, 3 plus beta into 1, 1, 0. So writing alpha plus beta, comma 2 alpha plus beta, comma 3 alpha, and combining the coefficients, we will get that alpha is equal to 1 by 3. If alpha is equal to 1 by 3, then beta from first coordinate, we will get that beta is equal to 2 by 3. And from second coordinate, we will get beta is equal to 1 by 3. But it is impossible. So 1, 1, 1 cannot be expressed as the linear combination of 1, 2, 3 and 1, 1, 0. And hence, V3 is not contained in V1. Now check the V4, subspace V4. Here it is 1, 3, 6. So 1, 3, 6 is equal to alpha into 1, 2, 3, comma beta into 1, 1, 0 equal to alpha plus beta, comma 2 alpha plus beta, comma 3 alpha. And here if you are just combining the coordinates, we will get that alpha is equal to 2 and beta is equal to minus 1. That means 1, 3, 6 can be expressed as the linear combination of 1, 2, 3 and 1, 1, 0. So V4 is contained in V1. Similarly, if we check 1, 0, minus 3, we can express it as the linear combination of 1, 2, 3 and 1, 1, 0. And hence V5 is also contained in V1. Hence option A and B are false and option C and D are true. Is the answer fine? Any doubt?
No, ma'am.
No, ma'am.
Okay. Okay. So let us see the other question. This is a question related to dimension of the subspaces. Let U and W be subspaces of a vector space V over a field F, and let dimension of V is equal to 12, dimension of U is equal to 6, and dimension of W is equal to 8. Then they are asking about the dimension of U intersection W and U plus W.
Option A, ma'am.
Okay. Yes, option A is the correct answer. So, can anyone say which concepts you have used to solve this question?
Ma'am, if U subset of V, in fact, subspace of V, then dimension of U is equal to dimension of V.
Yes.
Now, U intersection W is subspace of U.
Huh.
Now, dimension of U is 6. So, the dimension of U intersection W has to be at most 6. So,
Yes.
this concept, and then we have I have used the formula dimension of U plus V is equals to dimension of U plus dimension of V minus dimension of U intersection V.
Yes. Very good.
Then the
Yes.
inequality U.
Yes. Correct. So let us see the solution. This is the concept that we have to use is the same as he said. If V is a subspace of finite dimensional vector space V, then dimension of W is less than or equal to dimension of V. Since U and W are subspaces of V, then U intersection W and U plus W are subspaces of V. Thus, dimension of UW, dimension of U plus W must be less than or equal to dimension of V, that is equal to 12. So from this we can discard the option B, because in option B it is saying that dimension of U plus W is greater than or equal to 12. So this is not possible. Now, by using this result, what we can say? Considering U intersection W is a subspace of U as well as W. So dimension of U intersection W must be less than or equal to minimum of dimension of U, dimension of W. That is, dimension of U intersection W must be less than or equal to minimum of 6, 8, that is equal to 6. And considering U plus W, we will get that U and W are subspaces of U plus W. And hence, dimension of U plus W. U plus W means it is the smallest subspace containing U and W. So, dimension of U plus W must be greater than or equal to maximum of dimension of U, dimension of W. That is, dimension of U plus W is greater than or equal to 8. And hence, option A is correct. So, I hope that the answer is fine for you. Can we move to the next question?
Yes, ma'am.
Okay. So, this is a question from JAM 2025. Here again, they have given 3 subspaces V1, V2, V3, and they are asking the dimension of the subspace V1 intersection V2 intersection V3. So, I will give 2 to 3 minutes. You can try.
And 2.
3.
Okay. Any other answers? Okay, so majority are saying 2. Its dimension is 2. So can we start explaining the solution? Okay, so let us start. So here,
If we use that,
hello.
okay, continue.
Okay. So here we have 3 subspaces V1, V2, V3. V1 is such that it is satisfying its condition x plus y plus 2w is equal to 0. V2 is equal to 2y plus z plus w is equal to 0. And V3 is equal to x plus 3y plus z plus 3w is equal to 0. So what will be the V1 intersection V2 intersection V3? It will be the subspace.
3 conditions.
Yes, satisfying these 3 conditions. Yes. So V1 intersection V2 intersection V3 must be the set of all x, y, z, w such that x plus y plus 2w is equal to 0, 2y plus z plus w is equal to 0, x plus 3y plus z plus 3w is equal to 0. So here this is a system of linear equation. In fact, it is a system of homogeneous linear equations, isn't it? So the subspace V1 intersection V2 intersection V3 is nothing but it is the solution space of the homogeneous system. X plus y plus 2w is equal to 0, 2y plus z plus w is equal to 0, x plus 3y plus z plus 3w is equal to 0. So in the last class, we have seen how we are converting this homogeneous system into a matrix equation, or we can form a coefficient matrix from this homogeneous system. That matrix is, let it be A, 1, 1, 0, 2, 0, 2, 1, 1, 1, 3, 1, 3, and hence the dimension of V1 intersection V2 intersection V3 will be the nullity of this matrix, because we need the solution space. So this dimension of V1 intersection V2 intersection V3 will be the nullity of this matrix A, that is equal to 4 minus rank of A. This is by the rank nullity theorem. Is it okay till now?
Yes, ma'am.
Okay. So we have to calculate the rank of the matrix A. So A is equal to 1, 1, 0, 2, 0, 2, 1, 1, 1, 3, 1, 3. So we are converting it into row reduced echelon form. So when we are converting into the row reduced echelon form, we are getting rank of A is equal to 2. Rank is the number of non-zero rows in a row reduced echelon form. So we are getting rank of A is equal to 2, and hence this dimension is equal to 4 minus 2, that is equal to 2. Hence the answer is 2. Any doubts?
With due respect, I want to say something that it is time consuming process, right? So if we use the matrix form or that, if we see that the dimension is nothing but the Rank-Nighty theorem, but the dimension of the vector space minus the number of independent conditions of on the vector space. Now
Yes, sir.
the independent condition, it is very clear that if we add the first and the second equation, we get the third equation. So the number
Hmm.
of independent equations are 2. So
Yes.
4 minus 2 is 2. So it is 2.
Yes, yes. You can use that method also. Since maybe there will be students who have just started practicing this question. So for their understanding also, I am just explaining each and everything. But this method is very good for the competitive exams. You can manage the time.
Yeah, ma'am.
Yes. Okay. So here is another question similar to the question that we have discussed now. You can try it. You can take the screenshot. Okay. Now we have seen that means if we are discussing this solution
No, it is
space of
1.
huh?
The previous, yes, it is 1.
This one.
Yes, 1, I guess, the answer.
Okay, you can try. I means solution. I have tried, but now I don't have the solution.
No, it
Okay,
is clear that if we
x plus
subtract the second from the third from the second, we get the first equation. So here the number of independent is 2. So
independent.
3 minus 2 is 1.
Yes, 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 yes. T minus 2. Yes. Okay. So now we have seen that the solution space of the homogeneous system is, or the solution set of the homogeneous system is forming a subspace. So the question will come that what about the solution space formed from the, or the solution set formed from a non-homogeneous system? Can you determine the dimension of this set? That is, suppose the homogeneous system is x plus y plus 2w is equal to 1, 2y plus z plus w is equal to 2, x plus 3y plus z plus 3w is equal to 3. Then can you determine the dimension of this set? If you want to know the dimension, first it must be a subspace.
It is not a
Yes.
subspace.
Yes, it is not a subspace. So why it is not a subspace?
The null vector isn't present here.
Yes, zero vector is not there. So it is not a vector space. So we can't even this dimension is meaningless in this case. So I just want to discuss. Now let us continue with the question related to dimension. This is a question from JAM 2025. You can see that this vector space of polynomials are very, very important because most of the questions are related to this only. So try this question.
3.
Okay, 3.
Is it 3 or not?
It's not 3.
Oh, 1. Right, 1.
Yes, it is 1. Yes, it
The
is 1.
condition imposed is 3, right? Sorry.
Yes. So, let us discuss the question. Here,
Ma'am, can we solve this by using the linear transformation method or not?
linear transformation method, how to do? Means making into a means
Changing it
converting
into
it a
yeah,
matrix
yeah,
and analyzing the rank of that,
yeah, right,
right?
right.
Yes, you can do it. Yes. So here we are given the subspace P of x such that x into P dash of x is equal to 3P of x. So Pn of f, as we have discussed, is the real vector space, it is the vector space of polynomials over the field f. That means that for a0 plus a1x plus etc plus anx raised to n is an x raised to n, and the coefficients are from field. And a basis for Pn of f is 1x x square etc x raised to n. In fact, this basis is the standard basis of Pn of f, and hence the dimension of Pn of f is n plus 1. So now the question is related to P3 of R. So any polynomial in P3 of R will look like a0 plus a1x plus etc. a3x cube, means a0 plus a1x plus a2x square plus a3x cube, where coefficients are from real. And the condition is that x p dash of x is equal to 3p of x. So we just calculate p dash of x and then equate it. So here x into p dash of x means a1x plus 2a2x square plus 3a3x cube. And here 3p of x means 3a0 plus 3a1x plus 3a2x square plus 3a3x cube. So comparing these coefficients, we will get that a0 is equal to 0, a1 is 3a1, and 2a2 is equal to 3a2, and 3a3 is equal to 3a3. So from here, we will get that a0, a1, a2 are all 0. Only a3 is the independent variable. So the dimension of the subspace H is equal to 1.
1.
Yes, because H is just the subspace generated by x cube. That means the basis of H is x cube. So the dimension of H is 1. Okay, so I hope that the solution is clear. Any doubts?
No, ma'am.
Okay. So this is also a question related to dimension of the subspaces. This is a question from CSIR Net June 2023. It's multi-select question. So let us try. Okay. 4 is correct. Other options? Okay, 2 is true and 3 is false. So what about first option? First is false or true? Can you check again first option? I can see multiple answers. So the answer is option B and D. Let us see the solution. So here we are given V to be the vector space of all polynomials of degree at most 10 with real coefficient. So what is the dimension of V?
11.
Yes, 11. Now W1 is the subspace of V consisting of polynomials of degree at most 5. So what is the dimension of W1?
6.
Yes, 6. Now W2 is a subspace of V consisting of polynomial such that sum of their coefficient is 0. So that means W2 is equal to set of all A0 plus A1x plus A2 x square plus etc. plus A10 x raised to 10 such that the sum of the coefficient is equal to 0. So what is the dimension of W2?
10.
Yes, 10. So these are the dimension of V, W1, W2. Now the question is about the smaller subspace of V containing both W1 and W2. So W is the smallest subspace of V containing both W1 and W2. That means W is equal to W1 plus W2. Okay. Now let us recall the result. If W1 and W2 are subspaces of a finite dimensional vector space, then dimension of W1 plus W2 is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. So W1 intersection W2 is a subspace of V consisting of polynomials of degree at most 5 with sum of their coefficient is 0. So what is the dimension of W1 intersection W2? It will be 5, right? Because we are
Yes.
taking, yes, we are taking the polynomials of degree at most 5 such that its coefficient is equal to 0. Therefore, dimension is equal to 5. So by substituting this value in this equation, we will get that dimension of W is equal to 11. So W is a subspace of V and its dimension is equal to 11. That means this W is nothing but it is equal to V. Hence, the first option is wrong because dimension of W is 11. So first option is wrong. Second option is correct. And third option is also wrong because in W1 means it is a subspace consisting of degree at most 5. But W2 means the degree is at most 10, but the sum of their coefficient is 0. So we can't say that W1 is contained in W2. So option 3 is false. So, and option 4 is true because dimension of W1 intersection W2 is equal to 5. So, option B and D are correct. Any doubts? Can we move to the next? Okay. Can we move to the next question? So this is a question from CSIR net June 2024. You can take the screenshot. You can try. So now we have seen the vector spaces, subspace, dimension, and basis. So initially we told that we can the system of linear equation can be formulated into a question of linear transformation. So what is a linear transformation? Let V, W be vector spaces of a field F. A map T from V to W is a linear transformation if T of U plus V is equal to T of U plus T of V for all UV belongs to V, and T of CV is equal to C into T of V for every U belongs to, for every V, it is V, for every V belongs to V and C belongs to F. So the questions will come related to whether they will give some map and they will ask whether it is a linear transformation or no. So let us start with some basic questions related to linear transformation. First is a question from JAM 2023. We have to determine which among the following is a linear transformation.
And B.
Okay. What about other option? It is a multi-select question.
A is false.
Okay.
C is also false.
Okay.
Yeah, D is true. So B and D.
Okay. So option B and D are true. So how you concluded that option A is false?
Because T of x plus y means sine of x plus y, but it
Hmm.
is not equal to sine x plus sine y. So it is false.
Yes, correct.
But second option, trace of a plus b, we know the property of trace is trace of a plus
Hmm.
b is equals to trace a plus trace b.
Hmm.
So it is true. Now
Yes.
the option
Hmm.
C is T of x plus x comma y. So if we take T of a plus c comma b plus d, so it
Hmm.
will be a plus b plus c plus d plus 2. But it is not that it has to be a plus b plus c plus d plus 1. So it is false.
Okay.
And the D option is open because T of px plus qx means
Hmm.
p of p plus q of x. Now p of p plus q is a
Hmm.
polynomial at 1. It gives
Hmm.
the polynomial value of p of 1 plus q of 1. So it is clearly linear transformation.
Yes. Okay. Good. So first option we can discard. Because we know that uh, sin x plus y is not equal to sin x plus sin y. So T is not linear. And option B, you can just use the definition like T of A plus B is equal to trace of A plus B, and we know that trace of A plus B is equal to trace of A plus trace of B, and trace of T of CA is equal to trace of CA, that is also equal to C into trace of A. So that means T is linear. So option B is true. For option C, you can use this result also, because one of the necessary condition for T to be a linear transformation is that 0 must be mapped to 0. Means 0 of the domain must be mapped to the 0 of the codomain. But here in option C, T of 0, 0 is equal to 1. It is not equal to 0. And hence, in option C, T is not linear. And option D also you can verify just using the definition of linear transformation as well as the properties of the polynomial. Okay, so answers are option B and D. So using this condition also you can discard the option like if t of 0 is not equal to 0, then it will not be a linear transformation. So let us move to the next question, question number 13. Here they are asking about whether it is a 1-1 function or onto function. So this is a question from JAM 2025.
I think C.
Is it any other answers?
No, C.
C is not the correct answer. Yes, option D is the correct answer. Let us wait 1 minute for others. Let them try. Yes. Option D is the correct answer. I can see correct answers in the chat box. Good. So here we are given a linear transformation from R3 to R3. T of x by z equal to x plus z, comma 2x plus 3y plus 5z, comma 2y plus 2z, and they are asking whether it is 1-1 or onto. So here the dimension of domain and codomain of T are same. What is the dimension of domain and codomain?
3.
3. Yes. So here dimensions of dimensions of both are same, T is 1-1 if and only if T is onto. And this T is 1-1 if and only if T of xyz is equal to 0, 0, 0, if and only if xyz is equal to 0, 0, 0. So let us analyze this. So T of xyz is equal to 0, 0, 0 implies that x plus z is equal to 0, 2x plus 3y plus 5z is equal to 0, 2y plus 2z is equal to 0. Again, now we are getting a homogeneous system. So if 0, 0, 0 is the only solution of this homogeneous system, then we can say that T is 1, 1. So in the last class, we have discussed when this case will arise. Can anyone say?
What, ma'am?
When will means if we get only 0, 0, 0 is the solution of this homogeneous system, then T is 1, 1. So when this will happen? Can you say anything related to the matrix of this system?
If it is a full rank matrix,
Matrix must be
full rank.
Non-singular.
full rank. Yes, full rank. Yes, it should be non-singular matrix. Okay, so the matrix associated with the system is 1, 0, 1, 2, 3, 5, 0, 2, 2. So here we can see that this is not full rank matrix, or it is not a singular, not a non-singular matrix, because these two rows are dependent. And hence, the matrix associated with this homogeneous system is singular. That means it is not invertible. Hence, the system has non-trivial solution. So, the system has non-trivial solution means T is not 1, 1, and hence T is not on 2. So, T is not 1, 1, and T is not on 2. That is the correct answer. Option D is the correct answer. Okay. Any doubts?
No.
Okay. So, let us move to the next question. Here we are given a linear transformation such that some particular the values of this linear transformation at some vectors are given. The question is, what is the value of t at a particular value, like 1 by 2, 2 by 3, 3 by 4? This is a question from JAM 2025. What is that natural number?
Four.
Yes. 4 is the answer. Okay, let us wait for some more time. Let others also try. Okay. So, how did you do this question? Can anyone say?
Firstly, I have taken that x, y, z. How can we express it by 1 1 1? मतलब linear combination से कैसे इसको लिखेंगे? तो 1 1 1 1 minus 1 1 or 0 0 1. So I take x y z equals to some constant c1 into 1 1 1 plus c2 into 1 minus 1 1 and plus c3 into 0 0 1. So we get the values of c1 is x plus y by 2, c2 is x minus y by 2, but and c3 is z minus x. Now I see that t of 1 1 1 is 0 and t of 1 minus 1 1 is also 0. So the first two constant are we neglect it because
Yes.
it is 0, nothing but
Yes.
0. So the third term is important. So it is z minus x. Now 16 into, now z minus x means 3 by 4 minus half. So it is 16 into 3 by 4 minus half is 16 into 1 by 4, that is 4.
Okay. Correct. So here we have to keep in mind that a linear transformation is completely specified by its action on a basis of a domain. So here this 1 1 1 1 minus 1 0 0 1. So first we have to check whether this is a basis or not. If this is a basis, then we can find the value of t of 1 by 2, 2 by 3, 3 by 4 easily. So first we have to check whether this 1 1 1 1 minus 1 1 0 0 1 is a basis or not. So here we will get that this is a basis, is a linearly independent set, and as dimension of R3 is 3, we will get that this is a basis for R3. So now as he has mentioned, we have to express this 1 by 2, 2 by 3, 3 by 4 as a linear combination of 1 1 1 1 minus 1 0 0 1. As this first two means t of 1 1 1 as well as t of 1 minus 1 1 are 0, we just have to focus on the coefficient of last one. So this is the linear combination of 1 by 2, 2 by 3, 3 by 4 in terms of 1 1 1 1 minus 1 0 0 1. Now we just apply t of 1 by 2, 2 by 3, 3 by 4 is equal to 7 by 12 into t of 1 1 1 plus minus 1 by 12 into t of 1 minus 1 1 plus 1 by 4 into t of 0 0 1. Since first two terms are 0, we are neglecting it, and the last one is 1 by 4 into 16. So 4 is the answer. I hope that the answer is clear. So let us move to the next concept. That means how to form a matrix from linear transformations. We have discussed in the first.
We have to find the linear combination of the basis, standard basis term, and then we have to form the matrix by replacing the column vector as the
Yes.
coefficients of the basis terms.
Yes. There is no need of standard basis. We can take any basis also.
Any basis, right.
Yes.
But
So with
the matrix is with respect to this basis, so it is
yes.
important to mention.
Yes. We have to mention the basis because if we are changing the basis, then the matrix will also change.
Changes, right?
Yes. So we can means in the first slide we have seen that there is a connection between system of linear equations and matrix and system of linear equation and linear transformation. And here is the relation between linear transformation and matrix. Here if we are taking W and V to be finite dimensional vector spaces over a field F, then if we take any linear transformation from V to W, L of VW means it is a set of all linear transformations from V to W. Then corresponding to this T, we will get a matrix. How to get this matrix? As he has mentioned, we are taking a basis U is equal to V1, V2, etc. Vn of V, and we are taking a basis of W, W1, W2, etc. Wm, and we are expressing this T of Vj's, means T of these elements in this basis as a linear combination of the elements of basis of W. So we are getting that matrix Aij, and you should keep in mind that this is not, the matrix is not n by m. If V is a vector space, if V is a vector space of dimension n and W is a vector space of m, and if T is a linear transformation from V to W, then the matrix is of order m by n, not n by m. And this A is a matrix of T with respect to the basis U and set. So the bases are also very, very important. Okay, so let us see some questions so you will get to know more about this.
It will be capital A equals to small a ji or not?
So Aij, right?
But हम तो मतलब उसको घुमा के ट्रांसपोज करके तो लिखते हैं ना.
Yes. AT of V1 is equal to V1 is equal to, we are
Ji
writing A1, 1, A1, 2, etc. Okay. So AJI, you are saying I is equal
yeah.
to.
Then capital A equals to AJI.
Is it AIJ or AJ? I think it's AIJ. Let us see if through some examples. Let us discuss questions so that we can change, we can modify it if there is any mistake. Okay. So here also keep in mind that the rank of a linear transformation T is same as the rank of the matrix of T with respect to some basis of its domain, as well as trace determinant eigenvalues also. Means if they are asking what is the trace of the metric, what is the trace of the linear transformation, it means that they are asking it about the metrics associated with T. Okay. So let us see some question. This is a question. We have to find the matrix of T with respect to the standard basis. So what is the standard basis of P to T?
1x x square.
Yes, 1x x square. So you can try this.
What is 2a 2t means?
It is a spelling mistake. Sorry, typing mistake. 2a. It is subscript. Yes, A to T.
Two.
Okay, option 2. So let me clarify the doubt that you have asked here. T of Vj, whether it is AJI or AIJ, it is AIJ only.
No, ma'am.
Yeah.
I am saying that T of Vj equals to summation I equals to 1 to m Aij Wj, but the matrix will be Aji, right?
It will be AIJ only, I think. AIJ only. Because we want this m by n matrix. So if it is AJI, then J is varying from 1 to n, and it is I is varying from 1 to m.
If we continue the problem you give to us.
Okay. So let us discuss this solution. So here we have to, so the standard basis is 1 t square etc. t raised to n for Pn of t. So for P2 of t, the standard basis is 1 t square. T of 1 is equal to, means it is A1 plus 2 A2t. So T of 1 is equal to 0, 0 into 1, 0 into 2, a plus 0 into t square. And T of t is equal to 1 into 1 plus 0 into t plus 0 into t square. And T of t square is equal to 0 plus 2 into t plus 0. So the matrix associated with the standard basis is 0, 0, 0, 1, 0, 0, 0, 2, 0.
Ma'am, here you have written the matrix as in transpose form, right? So I'm
Yes.
telling this. If the theory of your note is right, then it have to 0 0 0, right, first row, but it is 0 0 0 first column. So
Huh.
the transpose of the matrix is the matrix of the standard basis. So it is AJI, right?
It is Aij. Aj, because here you can just see that T of Vj I am taking. It is not T of Vi. T of Vj is equal to summation I is equal to 1 to m Aij Wi. So if you are just taking T of V1, so T of V1 is equal to what we are getting. I term is varying, so it will be like A11 W1 plus A12 W2 plus etc. plus okay. So sorry, it is AJ only.
I'm telling.
Huh? Hello.
Yeah.
It is AJ only. Sorry.
Thank you, ma'am.
Okay. Okay, so let us move to the question number 16. This is a question from CSIR Net June 2023.
All options are correct.
All options are correct. What about others? Okay, it is a non-zero nilpotent matrix with index 10. So let us see the solution. So here is a vector space of real polynomials with degree less than or equal to 10. And the linear transformation is that we are taking the derivative of this polynomial. So here the basis is not mentioned. So we can take the standard basis 1 t square etc. t raised to 10. So the matrix formed from this linear transformation is this one 0 0 0. First column will be 0. Second column will be 1 0 0. Third column 0 2 0. And fourth column 0 0 3 0 0 etc. So this is a 11 by 11 matrix because the dimension of V is 11 and the domain and codomain are having same dimension. It will be 11 by 11 matrix. And from this we can see that this is a triangular matrix. In fact, it is a
Upper
matrix such
triangular.
as
Upper triangular matrix.
upper triangular matrix. And the eigenvalues are the diagonal entries. So all the eigenvalues of T are 0 and the determinant means the product of the eigenvalues. So it will be 0 and the trace will be the sum of all eigenvalues. So it will be also 0. And from this rank will be just only one row is non-zero. So the dimension will be 10. That means, sorry, not dimension, the rank will be 10. And hence all the options are correct. Okay. So let us try this question. You can try this. You can take the screenshot.
Yeah, the screen is not visible.
Is it? What about now?
Yeah, right.
Okay. This is also a question similar to the last one. You just have to form the matrix and
My
find
answer
the
is
rank.
3.
Yes, answer is 3. Yes. So you can. This is also a question from JAM 2025.
Again, not
You can
visible.
take this. What about now?
No. Yeah, right. Now it is right.
Okay. You can take the screenshot. You just have to form the matrix and analyze this matrix. Okay. This is also a question from JAM 2025, similar to the last one. Here we have to find the nullity of the composition. Is the screen visible?
Yes, yes, no, yes.
Okay. So we can take the screenshot and let us move to the another variety of question. So this is a question from JAM 2025. You can try this.
Again, no visible. Not visible.
Maybe it will take some time, maybe my network issue. What about now?
No, ma'am. Now it is all right.
Okay. You can try. Okay, let us wait for other answers also.
C.
See. What about others? Any different answer? Okay, so let's start discussing the question. So here they are given F1, F2, F3 be non-zero linear transformations from R4 to R, and kernel of F1 contained in kernel of F2 intersection kernel of F3. And the question is about T, where T is from R4 to R3, defined by T of V is equal to F1 of V, F2 of V, F3 of V. What is the nullity of T? Okay, so as F1, F2, F3 are non-zero linear transformations from R4 to R, since it is non-zero, we can say that rank of F5s are equal to 1. Thus, nullity of F1, F2, F3 will be equal to 3. By the rank nullity theorem, it must be equal to the dimension of the domain. So, we will get that nullity of F1 F equal to nullity of F2 is equal to nullity of F3 is equal to 3. Now it is given that kernel of F1 is contained in kernel of F2 intersection kernel of F3. But here this kernel of F1, kernel of F2 and kernel of F3 are subspaces of which one?
The screen is not visible.
Okay. Now,
Yes, ma'am.
so kernel of F1, kernel of F2 will be subspaces of
R4.
yes, R4. So kernel of F1 contained in kernel of F2 intersection kernel of F3 implies that kernel of F1 is equal to kernel of F2 is equal to kernel of F3 because we are in the R4 space and dimension of 3 here it is in the left side it is dimension of 3 and the right side also it is dimension of 3. So we can conclude that kernel of F1 is equal to kernel of F2 is equal to kernel of F3. Now the null space of T is equal to F1, F2, F3. So null space of T is equal to set of all V belongs to R4 such that T of V is equal to 0, 0, 0. That is equal to V belongs to R raised to 4 such that V belongs to kernel of F1 intersection kernel of F2 intersection kernel of F3. But all are same. So it is just equal to set of all V belongs to R raised to 4 such that V belongs to kernel of F1 equal to kernel of F2 is equal to kernel of F3. Hence nullity of T is 3. Any doubts? Is the question clear? Okay. I hope that the answer is clear. So this is a question, you can try it, you can take the screenshot. So these are some of the references that you can use for understanding the concepts in linear algebra. So today we have discussed many questions related to subspace, dimension, basis, as well as linear transformations. So all the questions, most of the questions are similar. Maybe the trick may be different. So in order to understand the trick and to solve it in time, you may need to practice a lot of questions. So practice, practice, practice is the only key to master maths.
Okay, thank you,
So-
Ardra.
Yes, sir.
Yeah, you can turn off the presentation and keep your video on. We can move for the feedback session.
Okay, sir.
So thank you, Ardra, for this nice session with a good collection of problems from the very recent examinations. And you have explained the answers in a very crystal clear manner. I appreciate your efforts for preparing and delivering this class in a nice manner. I also appreciate the participants for their active involvement throughout the session. I have seen many of them responding with the answers and asking questions and all that. It's really interesting and encouraging for us to arrange more such sessions. Dear participants, now it is your time to share the feedback. Feel free to share your comments with your video on, if it possible. Yes.
Thank you everyone for an interactive session.
Yes.
Hello, sir.
Yeah.
Hello, ma'am.
Hi.
I am Sneha, and I have completed my master's from ICT and now preparing for CSIRNet. And first of all, I want to say a happy Teachers' Day, both of you.
Thank you.
And this session was really helpful. Actually, I have studied linear algebra and revised theory portion, but I didn't practice more problems, so I was not able to solve on the spot. Since I tried, but I was taking so much time to get the answer. But some people are very fast, so I have recalled and get idea how to approach those problems. Some problems I was not able to approach how to think. So you have given lots of new things today. Now I can apply those methods, and it was really helpful. And sorry for that. I was in library, so I was not able to speak. Uh, but uh, from the next station, I will join from home so that I can be interactive. And thank you, sir. And thank you, ma'am. It was really helpful.
Thank you for the feedback.
Okay, thank you, Sneha. Others?
Hello, sir.
Yeah, yes.
Yes, sir. Happy Teachers' Day, sir, and happy Teachers' Day, ma'am.
Thank you.
I am Subha. I'm from West Bengal. And this session is very nice. Question explanation is very easily and very informative session. Thank you, ma'am, for your effort. Very nice.
Thank you
Thank
for the
you.
feedback.
Thank you, sir.
Yeah, yeah, thank you, Subra. Seeing you after a long time, I think.
Yes, sir. Yes, sir. I am traveling now.
Okay. Okay, anyway, thank you. Thank you, Subra. Okay, others?
Hello, sir. Hello, ma'am. Happy Teachers' Day. I'm Sneha. I'm a final year BSc student. And today's class is very interactive and it helped to gain more knowledge about the concepts and also to understand more problems. Thank you, ma'am, for this class, and thank you, sir, for arranging this class.
Thank
Okay,
you.
thank you, Sneha. Others?
Hello, sir.
Yes,
Hello, ma'am. Happy Teachers' Day. I'm Reshma. I want to first thank my sincere gratitude for organizing this class. It was incredible, beneficial for us, and greatly assisted in our revision for linear algebra for IIT JAM examination and other examination. Ma'am explained many important concepts and all our doubts clearly. They taught everything step by step with great patience, which made the class even more effective and easy to understand. And thank you, ma'am, and thank you, sir.
Okay,
Thank you.
thank you, Reshma. Thank you for your
hello, sir.
feedback. Yeah, yes.
Happy Teachers' Day, sir. I am Shubham. You can see me in the video.
Yes.
I'm MSc passed in this year, and ma'am Ardra ma'am is explaining so very well, and maximum questions are from IIT Jam 2023. So I have appeared this. So many questions are familiar to me as I have solved it in the examination hall. So uh, thank you, ma'am. You explained very well. Thank you.
Okay. Thank
Thank
you.
you for
Thank
the
you,
feedback.
Shubham. Yeah.
Hi, Sarah. Hi, ma'am. I am Mohammed Basil. It's my pleasure to appreciate both of you to have a great session for us. And I'm waiting for the. I have attended both of the sessions by you, and I am waiting for this session for for a month. And it's very nice today to have this session. Thank you, ma'am.
Thank you.
Okay, thank you. Any others?
Hello, sir. Hello,
Yeah.
ma'am.
Yeah.
Happy Teachers' Day, sir and ma'am. Ma'am, I
Thank
really
you.
enjoyed your session, ma'am. Your questions compared to last class, it was a bit of a higher level, but it's good that we have to experiment with more difficult questions, ma'am. Your explanation was really nice. I'm hoping for more classes from your side for both IIT JAM and, if possible, ma'am, TIFR level questions too, ma'am.
Okay, we'll try.
Sure. Thank you, ma'am. Thank you, sir, for organizing the session.
Thank you,
Thank you for the
Arsina.
feedback.
Any others? So some of the participants have shared their feedback in the chat box. If any of you would like to share some feedback, please make it now. Okay. I think we can wind up this session here. Okay, once again, thank you, Ardra. Please do share the feedback. Please do share the PDF of the today's presentation. We can attach it with the recording of the today's session.
Okay, sir. I will rectify the mistakes and I will share them.
Okay, thank you, Ardra. So, and also, if whenever time permits, just think about for further sessions. I know that you are busy with your research and all that, but you are really a talented teacher. That is, all these participants are sharing very positive response on today's session. So it will be good if you can do more sessions in our platform. And okay, of course, you have to have the strict schedule of your research and all that. So just think about it, and whenever time permits, we can arrange it. Okay.
Okay, sir.
And
Thank you
once-
all students also for your interaction.
Okay, thank you, Ardra, and wish you all the very best for your academic career. Thank you.
Thank you, sir.
Okay,
Okay.
let us wind up
Okay,
here. Bye.
Okay, bye.